click on file, go to new, then create your library name. And click on OK. Click on GPDK Partition Animated Technology, then click on OK. Then again go to new, cell view, as we choose our library, then give cell name. Click on OK. Then go to add instance and select 2:4 decoder. As we place 2:4 decoders as 2, then go to browse, and take one inverter for inverting the enable. And inverter of ground, and all the grounds are connected, and inverting enable is connected to another decoder, and both pins, both input pins A and B are connected to and connected, and VDD pin is connected to both the decoders. Please subscribe my channel. Now create pins as input and output, and we create input pins as one A and B, and one enable pin, and one enable pin is inverting is given to another decoder as worked as third pin, and create output pins as Y0 to Y7 as total 8 pins, and 3 input pins, and 2 input pins as ground and VDD. Now place the output pins and make to connect. And ground is connected to ground Y, and VDD is connected to VDD Y. And now all the check the interconnections, and then check and save. Then go to create. For creating a cell view, let's click on from cell view and rearrange the pins for our correct symbol as left pins and bottom pins, and right and top pins. Now create a file and create a cell view for call the symbol and give cell name as test bench. Now call our symbol, then go to browse, then select our previous folder, then view a schematic, symbol, then place it, then we select V pulses in cell and search for V pulse and symbol, then close and click on hide and place the V pulses as take 3 V pulses for 3 input pins as A, B and enables. Now as usual in analog library take cell as VDC and same as ground. Now each ground is connected to each component as 3 V pulses and symbol of ground and VDC of ground. Then create a input and output pins as input pins are A, B and enable. And same as output pins are Y0 to Y7. Here we create output pins from Y0 to Y7 as total 8 output pins. Then place correctly and create input pins A, B enable, then connect it to V pulses. Each pin is connected to correct V pulses and V pulse is connected to symbol of input pins. Make the connections as we connected in this video. Then click on component as V pulse and hit a Q on keyboard. Then same as displayed as V pulses parameters and give voltage and pulse width and period as pulse width is half of the period. And same as input V pulse B. Then click on Q as all voltages are same and change the period for different V pulses for our better waveform. Same as enable parameters, same voltage and change period. Here we give delay and rise time and fall time. No problem for you not given. And give VDC as DC voltages same as V pulse voltages. All voltages are common. and check the parameters once. Here remove fall time and rise time. And also change enable parameters. Only give delay for any V pulses. Now check and save. Then go to launch, click on ADL, then right click on analysis, then go to setup, go to model libraries. Here choose transient time analysis, click on OK, and right click on analysis tab, give stop time as for our convenience as and moderate analysis, and click on and right click on outputs. Then go to from design, then select the input and output pins, select all input and output pins. Then go to ADL, then click on netlist and run. For waiting for our output waveforms as transient analysis. And here is our output waveforms. Then check the truth table. Here we use one enable pin as one input pin as third pin. If enable pin is 1, output activates from D0 to D3, sorry, Y0 to Y3, and from enable 0 active Y4 to Y7. We see in our schematic, as per our schematic, inverter output is given to another decoder, non-inverter input is given to first decoder. So here we give input enable as 1,